Are there a set of milestones that are like meaningful to you?
I'd say when Gemini 3.0 writes Gemini 4.0.
I was kind of showing this to my mum like a couple of days ago.
Moms are the ultimate test of whether like something has broken the barrier from like the Twitter sphere to like the real world.
The mum vibe check is a big deal.
What do you feel like's overhyped in the AI world today and what's underhyped?
I have a few, but I think they're all too spicy.
There's no such thing as too spicy on my podcast.
It's always going to be this kind of whack-a-mole of like what is considered actually interpolating known ideas versus like creating a completely novel idea. And for that one, I'm going to go to
Noam Shazeer and Jack Ray really need no introduction. The two are at the forefront of Google's Gemini LLM efforts and have been involved in some of the most important discoveries in AI in the last decade. Noam as one of the co-inventors of the transformer and mixture of experts. Jack, a key part of many DeepMind breakthroughs. It's a real privilege of the job to get to sit with these two and ask them literally every top of mind question in AI today. We talked about how far test time compute will get us and the spaces where it will and won't work. We talked about how the infrastructure needs will be different for test time compute versus the large kind of pre-training paradigm. We also hit on the impressive pace at which open source models have caught up with closed source peers and their reactions to DeepSeek. We talked about their kind of reception and reaction to Ilya saying that this test time compute paradigm won't get us all the way to AGI, as well as Jan LeCun saying this current generation of models can't actually have any novel thoughts. We talked about what it actually looks like to do cutting edge AI research today and what their day-to-days look like, as well as the future model milestones that actually matter to them. And then we also got Noam's reflections on character, as well as both of their responses to what, AGI means for the role of humanity. I think folks are going to love this. It was really just a pleasure to get to speak with both Noam and Jack. Without further ado, here they are. Well, Noam and Jack, thanks so much for coming on the podcast.
Oh, thank you.
Are we sitting in the very office that the transformer was invented?
No, this is a new building. We were in 1965, Charleston, I think. No, probably about half a mile.
Half a mile. All right, so it's in the air.
Pretty close. Pretty close. Yeah.
Well, many things to dive into today. I mean, obviously, want to start with some of the latest Gemini 2.0 models, and obviously all the work you've been doing around test time compute and Gemini 2.0 flash thinking. I guess just at the highest level for our listeners, how do you characterize where these models work today, where they don't work as well? And as you were kind of experimenting with them, what surprised you most about those results?
One surprising thing is kind of when we started the particular concerted effort to build a lot of research and into test time compute, into Gemini, and then think about shipping it, is that we were really kind of focused on starting out with reasoning tasks. So math and code were like big areas of focus. And it wasn't really clear, whilst we're kind of sprinting in that kind of domain, we obviously want to broaden it naturally over time, but it wasn't really clear like how that would work. Would there be any kind of sense of generalization? Would thinking be useful beyond those reasoning tasks if we're just concentrating on those as researchers? And I think it was pretty fun to see one of the early kind of models that we felt like was had been trained to try and match the style of Gemini Flash. So it had been trained with thinking, but then it had also undergone some kind of training to actually be just like generally a nice style, a nice like model to talk with. That it was actually like very fun seeing thinking interact and improve like creative tasks as well. You could ask the document to like compose kind of an essay on a particular topic, and actually like the thought content was like very fun to read, and it would go through like various different ideas, and then it would go through like revisions of the idea or things that it should cut, and that was kind of fun. And then also the output like felt really nice. So that was one thing that kind of surprised me.
Any surprise for you, Noam?
Well, I mean, in general, like I'm all for like generality. Like let's train something that's great at everything. It is important, and I was skeptical at first of like, okay, this intense focus on things like math, but it is very important to have good benchmarks that are going to encourage you to to be able to reason about difficult tasks, because a lot of things will drop perplexity, like add more parameters to the model and memorize more. So it's nice to have the evals that can distinguish better, some of the more difficult problems.
I mean, what evals are even meaningful to you at this point? I mean, obviously, I feel like people are trying to hill climb the same set of evals that feel increasingly less relevant to day-to-day work. What do you guys do when you're testing these models, or how do you vibe check them?
It feels like we keep landing on an eval, and we're like, oh, actually, we overlooked this eval, even if it's in math. It's like, okay, we've done a bunch of math evals, but maybe I don't know, Putnam answers only, AIME, they're still considered challenging, and then it's done. Okay, they're completely saturated, and we really don't care, and they're small, and we almost think, why did we ever even work on them? And it's easy to forget.
God, that was so easy what we thought 6 months ago.
Yeah, a couple of months ago, it was considered really hard, maybe too hard for the model, and then it suddenly snaps to being trivial. So right now, I do feel there's always been a lot of concerted effort within DeepMind and within Google as a whole to develop useful evals. But it's kind of very nice to see also this is a shared responsibility across many different AI labs, and even Scale has started really stepping up and developing
I feel calling it humanity's
evals.
last exam was a dangerous, if every 6 months we think it wasn't too hard, it's a dangerous title.
The really, really last exam.
Yeah, exactly.
But the whole thing is
73 last exam.
It's very, very challenging in general because evals get leaked. Once people start talking about the evals, then there's all this text out there about the evals, and they're no good anymore because everyone knows the problems, and all the models will know the problems unless you're very, very careful. So there's I think there's still a lot of work that goes on into having evals that are that are private.
Are there a set of milestones that are meaningful to you? It's hey, when Gemini 3.0 can do X, that's a really exciting milestone, whether it's an eval or just something that you've tried with these models and they can't quite do yet.
I'd say when Gemini 3.0 writes Gemini 4.0. Or I should say Gemini X writes Gemini X plus 1. Yeah, I think these reinforcement loops are probably the most important thing to pay attention to. And there are several reinforcement loops going on. The one I just mentioned is probably the most important one, that we can actually use the AI we're building as a tool to make ourselves more productive at building AI. But then then there are other reinforcement loops around data flywheels. You get you have people use these models and provide feedback and make them better at the things that people care about. I think we'll see huge acceleration from that. And then there's just the global excitement and funding flywheel, which is I think also seems to be kicking up in the last few years.
Yes, certainly so. To your point, I guess, of having you kind of armed with 1,000 AI engineers by your side, making you even more productive. Where are we in, do you have the equivalent of a 0.1 of an FTE today of using some of these Gemini models alongside your research?
Yeah, I think one benefit we have at Google is we work in a very structured mono repo. Yeah. So, and we have a lot of amazing tooling around contributing to the code base already. So there's lots of angles where AI is kind of being pulled in as tooling for our own development. I think Jeff quoted the statistic, although I don't know, but the number of what we could call pull requests that
it was 25%, right?
Yeah, useful AI, just AI bug fixes or code reviews attached. That's already that just gets pulled in one day. I notice it there. I'm oh, that's cool. I can now do a lot of apply fixes that it already spots. But that's just one element where we're already pulling in AI towards our own coding development. I think we're incredibly excited about agentic coding is just definitely very important, and trying to get the model to be able to tackle more open-ended and difficult tasks is definitely something we're very excited about. And I think it's just in some ways it's a lot easier to orchestrate when we have a very defined way of defining libraries, we have these build rules and things, and it's just everything gels together in terms of the whole code base very well. So I can imagine it's going to be as progress kind of continues, it's going to be a very discrete moment where suddenly lots of libraries can be very quickly iterated on within our code base.
Yeah, and you'll get your AI engineers proposing experiments to you of what's good to try. It seems like these models work super well in easily verifiable domains and coding and math, and have obviously been among them. Like, how do you think about how, for some of these less easily verifiable domains, these models may end up scaling and being useful?
I mean, they're getting better at that stuff too, but yeah, it's definitely harder. I guess in those domains, we're going to need either better ways of verifying or more human feedback loops.
Yeah, I think what's good is that we're seeing is like, even with the Gemini model series, they're able to follow much more abstract instructions. So being able to try and provide a reward signal over a qualitative piece of work, which maybe if a human were going to try and give a feedback signal, there would be quite a broad set of like rubrics or like grading criteria, or maybe there is even more like a even kind of simplistic sense of like what is good style, what is like interesting, and so I think part of the problem is really training models to like take on these like very broad criteria for what how to like take in a very broad set of criteria and then apply a reward signal. Once we have the reward signal, we can train with reinforcement learning against it. And I think, yeah, we're already seeing that kind of like makes sense. It's not like an abstract thing anymore. It seemed like a very abstract thing maybe a year ago. Yeah. Or 2 years ago.
I'm curious, a year or two ago, like, did you expect that to work? Or do you think this like whole path of research was really more toward these like more easily verifiable domains?
I feel like you expect it to work one day, and then it feels like there's a very complicated stack of things that we feel like we need to solve to get there. And then usually the case, it's like, oh, it turns out there was a much simpler path. That's how I feel about it anyway.
Yeah, usually there are good surprises, more good surprises than bad surprises.
You've released these models out in the wild. What are some of your favorite kind of like ways you've seen people using them? And what would you like to see more people like trying and building with these things?
Actually, there's just like an update today happening in the Gemini app where we're putting in a much stronger model, and it's being integrated with basically the full suite of like Gemini app tools. So it's like all of the apps that Gemini app supports, from things like, maps, also like search integration. It now has like very long context. All these things, it's kind of like a fully featured Gemini thinking release in the app. And it is actually, it's a very enjoyable experience. That's what I think so far people, even for their day-to-day stuff, people, it wasn't clear to me whether they would like to have to pay a bit more latency to like get the model to think about stuff before responding. It does seem to be the case that if people are going to like pull their phone out of their pocket and then type something in, that actually what we thought was a very long time, maybe a couple of seconds, is like a very small price to pay for something that they feel like is a better quality answer. And also maybe they can like sometimes look at the thoughts and inspect them. I was kind of showing this to my mum like a couple of days ago.
Like moms are the ultimate test of whether like something has broken the barrier from like the Twitter sphere to like the real world.
Yeah, like the mum vibe check is a big deal. Yeah. And yeah, I guess she asked a lot of like what I would consider very generic questions to ask a model, like what is the meaning of life?
Meaning of life.
Yeah. She went for what is the meaning of life, and she really like sat and read it for a long time. And then she read the thoughts as well, and then she kind of like contemplated on it, and she felt like she seemed to kind of very much appreciate the presence of like thoughts as to like how to even go around such like an open-ended question.
So more folks building philosophical conversations with these models. Well, I mean, one thing I think is super impressive about them is the multimodal capabilities, but it still feels like those are very underexplored from an application perspective. Not sure totally why that is, definitely. But
yeah, I think right now, in some ways, we're quite modest about the multimodal capabilities of Gemini. I feel like the model has always been incredibly strong at image input. Image input plus thinking is like actually like remarkably good, I would say. I see a lot of people kind of like red teaming the model on things like on X and trying like difficult or challenging like images, visual reasoning problems. I think that is working pretty well. There is also like at some point, some of those are kind of toy evals, but pulling in multimodal with then agentic tasks is super interesting as well. So like we launched Mariner last December, which was like an agent which like uses a browser and things. That has a lot of multimodal like aspects all built in. It was super important that they could get the model to be incredibly strong at like not only kind of scanning a screen, but like really understanding it and knowing how to act on many, many different types of websites. So like pairing that kind of capability, Agentic, quite open-ended, maybe you really need visual understanding of a potentially messy scenes with thinking is something that I think I'm feeling very excited about.
Yeah, that's one. I mean, it made sense to start with text. You know, a picture's worth 1,000 words, but it's 1 million pixels. So like the text is still like, you know, 1,000 times more information dense, you know, just to do math on cliches. But, and then there's also like a lot more just in-domain training data for text. You know, we have so many examples of text which actually kind of represents, you know, the way humans receive and produce information, you know, through language. But, you know, we have a lot fewer examples where for something like, say, image generation, because you don't have examples of people generating images, so things are a little more challenging. But we, you know, it's as Jack said, you know, great stuff happening.
Yeah, when you mentioned Product Mariner, I'm curious. Like, you know, I think we both talked before about, you know, to get really, you know, agents more widely used, you kind of need to solve both complexity of reasoning and then also reliability. How would you kind of characterize where we are today in terms of applying, you know, Gemini models toward these problems, and like, what is the actual path to getting better at a bunch of these things?
I mean, there are a lot of answers. I mean, one is just make the model smarter. That will always help. And you know, most likely you know, you need very general solutions for you know, for these control problems. You know, just like you need general solutions for the intelligence problems, because you know, people are going to use these things in so many unforeseen ways. You know, like you can't anticipate it. The users are smarter than the developers in figuring out what the use cases are. You know, that no one envisioned, like when they invented the internet, like what the internet was going to be for. No one envisioned when they invented computers, what computers are going to be for. And then you know, AI is, you know, is getting so general these days that it's even more true. We're just building a product with billions and billions of use cases that are unanticipated. So we will need to build the general solutions for all of it.
How far away does it feel like we are from that kind of like next level of complexity and reliability?
I don't want to give a precise, like, is it 6 months? Is it 18 months? Is it 24 months? But I think a lot of the time actually is not so much dependent on in my opinion, is like not really about like the core algorithmic AI development. There's part of it is just like, there's a lot of even like engineering challenges to really changing the whole way you train to being in more complex agentic environments that has like some like almost constant time but non-trivial cost to like switch how we do research. So I feel like agentic research, it seems like a lot of the upfront challenges, like it's no longer going to be very simple prompts and responses. We're now going to act in an environment. So how you define those environments, that kind of angle, though, is at the very least been something that DeepMind has been brought in on even since I joined in 2014. It's always been about, there's part of building AGI, which is like figuring out a really good agent, and there's part which is figuring out a really good in general environment. I don't think anyone has solved the perfect environment yet. And you know, there's some obvious ones. There's a notion of like using a web UI and like kind of being able to automate many kind of like web tasks. There's a notion of like having a code base and being able to like work within that code base and do many useful things. But I think picking out those, like, if you can pick out a really good environment, then we can like accelerate a lot of agentic research in that environment and build really good algorithms. And I feel like that's as big a part of the challenge as any given breakthrough in like attention or in long context or reinforcement learning.
How high do you guys think the ceiling is for continuing on this like test time compute vector? I mean, obviously, I think very publicly, like Ilya's come out and said there's this entirely, new direction that's needed to really advance AI to the next level. Do you agree with that?
Yes, I pretty much agree because LLMs are just too cheap. Like if you operations cost under 10 to the negative $18 these days. So if you can infer relatively efficiently even on a very large model, you're getting like over 1 million tokens per dollar. If I guess you can just check the prices on Gemini or anybody else, and so you're getting millions of tokens per dollar. That's way orders of magnitude below the cost of most other things you can think of. Like if you think of like a really cheap pastime, like go buy a paperback book and read it or something, you're paying like 10,000 tokens per dollar. Yeah. So we're like a couple of orders of magnitude cheaper than like reading a book, and probably 4 orders of magnitude cheaper than paying anybody to do anything, and whatever 6 to 8 orders of magnitude cheaper than paying a software engineer. So there's a huge margin of difference there to apply more compute and make the thing smarter. If the value is there, which I think it is, would you pay 5 cents an hour for the bad engineer or 10 cents an hour for the good engineer? There's there's a huge amount of sort of unexploited flops in there for to use if we can find ways to use them. And one way to use them straightforwardly is just train a bigger, better model. We're already doing that, but still model training costs tend to go up quadratically with the size of the models. So then you still end up with relatively cheap inference if you do it right. So then, of course, what everyone is doing now is just apply more compute at inference time through this chain of thought thinking or any other brilliant algorithms we can come up with. And so I think we're just going to start seeing a scaling curve there, as well as we're seeing in a lot of places.
Right. But does that scale us all the way to the AGI future people envision, or is there some kind of completely adjacent thing that's required to I guess where does it asymptote?
Yeah, I guess that's where we'll see whether it's the humans that invent the next breakthrough or the AI. But I'm not. I've given up on organizing my garage and stuff like that because I'll just wait for the robots.
Yeah, you think they're coming? I guess you guys had a big robotics release yesterday.
Yeah, that's awesome. Yeah.
Is it ready to clean your garage though?
Not that I know of, but
yeah, I think the question of how much more is there to give in this test time compute paradigm? Is it all the way to AGI? I don't think it's all the way to AGI. I think we already kind of established there's other components. Being able to act in a complex environment, acting is very important. Research into acting agents, that's a definite investment. And there's many other aspects, but are we seeing kind of test time compute asymptoting? I think the kind of Ramanujan example is always in my mind here, where it's I don't want test time compute to just, for any given problem, think longer and then eventually arrive at a solution. But we also want it to be able to think very deeply and actually create maybe useful knowledge that it's going to actually incorporate to then solve further tasks in its thoughts. And thus dramatically improve data efficiency. If you can just have one math textbook and you spend most of your time really just thinking and playing around with the ideas, and then you can become a world-class mathematician, that would be the kind of thing that I feel should be and we should strive to achieve with like a very deep thinking model. Are we there yet? No. Like, do we have a path there? I think there is. Like, there are many directions of gradient towards such a model. We've been already seeing, and this is one thing I think people don't really like talk about too much with test time compute, but we're already seeing like amazing improvement in data efficiency by training the model to like think deeply with reinforcement learning when it's solving the task. So even if we're, going to have a bunch of like RL data, we're not going to add any more. Even just like the test time compute kind of paradigm is allowing us to kind of learn a lot more from that data. And I think we could probably push that much more so. There's kind of many particular research angles we're interested in and how this model could think not just in one particular, spitting out a couple of thousand of tokens in order to solve the task, but maybe like think much more deeply, much more kind of like a researcher might think about a hard and open-ended problem.
I think so much of what you guys have touched on is like these models increasingly acting like researchers. What are like the early signs of that you would look for?
I think like, I'll give one example, which is like math. So I think right now math is being treated as it's a bit strange. Math is often used as benchmarks, and they're kind of like exams and maybe even like math competitions. There's going to be like a very important pivot from the math benchmarks and to being really starting to become about like actually generating useful math, starting to solve actually important problems that we really care about. I think there are ways, like I think it was very cool, this like frontier math eval that was created, which is trying to provide like a kind of a gradient towards that. So maybe like the harder category are basically almost like unpublished math findings. The easier category is supposed to just be like kind of harder or trickier. I don't know whether that particular eval is the perfect way, but having some kind of ramp of evals that like bridge us from where we're at now to like actually useful scientific contributions. This is something I'm like especially excited in, as bringing in professors and researchers and saying, okay, use this tool in a non-ironic way to actually accelerate research in this area. What would you do? What's missing? What do we need to advance? And I think, I think like this kind of notion of like incrementally harder benchmarks, it might sound like, oh, that's like what AI researchers always say, but I think that's going to basically be my metric of progress.
I mean, math is a great example here because, I mean, this is a field that you don't actually need more data. Like, like people invented all this math without this external input or
a lot
or
less
world
data.
outside.
Oftentimes in like a room, just thinking through things.
Yeah, you just go into a room. And then there are examples where, okay, there's some data, but, Isaac Newton like takes a bunch of astronomical observations, like goes into quarantine and like, in his house and then like invents physics or something. So, okay, that's an example where there's data, but nobody actually knows, knows physics, and then you generate physics. And then math is even crazier because you start with, with roughly no data and invent something useful. So that's that kind of could provide a counterproof to the assertion that, hey, this is just learning to mimic people. That okay, the most we can do with AI is to relearn what everybody knows and what we've.
And obviously, the learning to mimic people critique, I feel like, has been around for a while. I feel like Jan Kuhn said a lot about this. Like, do you feel like that's entirely disproven at this point? Basically, the critique that like novel discovery and thinking is kind of impossible in these current model architectures.
Oh, well, there's definitely one class of scientific discovery that I think almost no one could argue against, which is like actually a lot of science is like, if you knew about these two disjoint pieces of information and thought about the intersection for a while, you would realize a new property. Like in kind of material science, it might be like, oh, it turns out just like associating things way better means actually you know way more about like what new kind of material may be photovoltaic, but also may, et cetera. So there's like interpolation already would actually completely accelerate science. And I'm guessing then it's always going to be this kind of whack-a-mole of like what is considered actually interpolating known ideas versus like creating a completely novel idea. And for that one, I'm going to go to Noam.
Yeah, okay. I don't know, but I guess I'd just throw it back at Jan LeCun to prove that he generated a completely novel idea. We'll see. I don't actually care about arguing this stuff. Let's just build AI. Greatly increase the level of technology in the world. Help people. That seems good enough for me.
Even if we go back to the math example, like the thing I'd love to see is like, maybe the state of mathematics right now is kind of like the state of kind of geographic exploration in the 15th century or something. So it's like there's some known things. There's some fuzzy area of like we don't really know what's like beyond these boundaries, and we have a bit of a guess. And then you send a small number of people to go off in a boat. It's very expensive to try and like push the boundary of like what is known and what is not known. And
they come back with some pretty funny looking maps.
Yeah, they come back with like a little bit of extra territory, like explored, and then they tell people. And that's a little bit like what's happening right now in mathematics. You have a very small number of like elite math professors that are able to really ask the right questions and then actually like prove useful qualities, and it kind of grows, and it's grown that way, and that's how it's been going so far, right? If we can train a model that can actually like essentially ask, like it can pose the right questions of what you could say is like the space of all useful mathematics is kind of an infinite space. You don't want this to go and like off like a fractal on kind of uninteresting questions. But if there was some notion of like all the set of like interesting mathematical questions, if it can like keep posing new ones, and then if it's very, very strong and it can solve those, then at some point, maybe like right now we have a pretty strong kind of math model, and at some point maybe it will be a professor level, maybe one day it'll be Terry Tao level, and then you have like 1 million of them, and then now it's like, I think then you could hope to maybe complete the map. And then what would like completing the map look like? That could be one of the greatest contributions to kind of science. You would now, physics, chemistry, you'd now like be able to have like a very deep understanding of like any useful mathematics. I think that would be like a very, very exciting thing. Whether it's possible, I'm not sure, but I would agree maybe the key crux is like, can I ask in like actually novel questions? The question posing thing seems to be the hardest part, in my opinion. The solving, I feel very confident we will get there.
But maybe mathematics is infinite.
Yeah, I mean it's definitely infinite.
Yeah,
so then
but we can do so much better.
Yeah.
I guess maybe just talk about the culture of AI research a little bit. Like, Noam, you were obviously part of the, a leading part of the original Transformer paper. Both of you have been a part of so many breakthroughs. People like to write these thought pieces about, the culture that drove these innovations. Curious, like, what you think the main takeaways you have after, having done this research, some periods of great success, some periods maybe of more frustration. Like, what lessons do you take away from what actually, works from a cultural and team structure perspective to drive this stuff forward?
Maybe sort of AI research is kind of where chemistry was in the 15th century.
Say more.
Alchemy. It's alchemy. Like, we don't know why it works, like, but it's highly experimental. In terms of you get some idea, but really the proof is always in try it out, and then then you have various observations. You come to hypotheses about why, okay, this thing works. Why? What's the key thing? And so sometimes you're right, sometimes you're wrong. It usually takes more experimentation to find out, or you can just claim that okay, it works because of my magic XYZ, and you have your assistant swallowing frogs or something, and or the equivalent. I find naturally researchers just love to share and get excited about about what they're doing, and it is always important to try to credit people liberally, because it's often very, very complicated to okay, what idea led to what idea, what was the key insight. And I think at some point we'll we'll just kind of have to give up on credit assignment temporarily and take a superintelligence-based approach of we'll wait for the superintelligence to sort it all out.
Who gets credit for what?
Once we get it.
Superintelligence will write some great thought pieces on the culture that drove these transformations.
But it is super fun working at Google with this group of brilliant people and collaborating with everybody.
And one thing I'm struck by the Transformer story, I think, is like, it involved, I think you were like, you heard randomly that some people were working on, and, when you tell the story, it sounds like, wow, that could have easily not happened. Like, I don't know, if you weren't walking down that hall one day, does it feel like inevitably someone 6 months later would have figured that out? Or like, how much just random happenstance is there that kind of leads us toward a different path from just people in this building colliding in different ways?
Oh, interesting. Yeah, we would have all been using LSTMs or something. I mean, I guess maybe it's like, okay, you ask the same question about like, okay, if somebody hadn't invented like an internal combustion engine, would we still be using steam engines at this point? I mean, I think someone would have come up with something like Transformer.
From my vantage point, like over in London, it did feel like you were circling around there was like neural GPU, there was which was also like, okay, the key thing is we're not going to have an RNN anymore. We're going to parallelize, but it's not just going to be a convnet. We're going to have like a notion of like depth is going to be some kind of function of your sequence length. That was an idea in the neural GPU. It didn't quite work out, but it was like the key idea of like get rid of RNNs felt like that vibe was there.
Right, because there were all this work on convnets running around. Everyone wanted to kill the LSTM, and attention had been floating around from the translation models. So it kind of needed to come together.
I love that. Also, kind of on the on the culture side, I think one of the interesting things of how I understand Google works is basically there's like this bottoms-up compute allocation, right, of folks getting to do different projects and then convincing other people to kind of come and allocate compute for that. And obviously that's one model. There's other places that are like, we're going to go all in on like one thing and are much more top-down on the compute side. How do you think about like the trade-offs between those two models? And
yeah, I mean, we've been through both, or I've been through both. I guess Google Brain, when I was at Google previously, was mostly bottom up, as you describe, and then DeepMind has been mostly top down.
Yeah, it was a bit more top down.
A bit more top down, and different philosophies, and there are pluses and minuses to both. I think top down can be good for getting people to collaborate. And getting like larger training runs working, but bottom up I think is also great for collaboration, because then like okay, you bring someone out new on your project, it doesn't mean you have fewer resources per person, you have more total resources. So so that's great, and that there are so many abstraction breaking ideas that there's no great way to categorize them. So if you're saying, okay, this is the compute for pre-training and this is the compute for post-training, well, okay, you've got something completely different that doesn't fall into those things nicely, and then it falls between the cracks. So we're bringing back a good measure of bottoms up, because I think that's super important.
Yeah, it feels like an interesting balance to strike.
Yeah, like I guess so I worked at OpenAI briefly, and I did like the way that concentrated bets were made, and that like obviously paid off like well for them in certain areas, and that was nice. I also like the way concentrated bets were made at DeepMind, especially kind of like I do think there was a bit of a vision sometimes for like say AlphaGo. I was asked to join the AlphaGo team right at the beginning because they needed an engineer, and I was a research engineer, and I just didn't get it. I was like, why would anyone care about a board game? I don't get it. So you do really need like good research leads that have vision to drive these things. You can't expect everyone from that doesn't have always the best like vantage point to like know where the impact is going to be. Right now within like, for example, thinking as like the area of research that we kind of work within, it's like incredibly important we have a reasonable, non-trivial investment in like just bottom-up research where we're really not dictating anything. And then it's just a fun process of, it's kind of a fun meta research process of like, how can we make these people maximally efficient? How do you make your baselines lightweight? How do you make these signal bearing? How can people move as fast as possible? And that's very important. And then it's just very important that it can't all be that. It needs to be, and here is a mandate of top-down bets that we have to deliver on. But it's always humbling. Like, I think we have a very good like scope of like what everything is happening, and we get a sense of like, here are the areas that are going to be really important. And usually you get humbled by the bottom-up research of like a thing that you weren't even thinking about ends up being way more impactful than you thought. So just like always keeping that running is super impactful.
Yeah, I mean, reflecting back on the past decade, like, are there, some of these like inflection points or these like decision points where it's maybe like, hard decisions, 51-49 that like ended up being kind of super impactful?
I mean, I think for both of us, like going in on large language models was good.
Yeah, I'd say that was probably a good call.
Yeah.
and it kind of seems obvious now, but it kind of was, at least, I mean, I found it was like in a state of being not obvious to most people, but obvious, I felt like, to a small number of collaborators that like this was definitely gonna be a big thing, and kind of had to go against the grain for a while.
Yeah, that's true. There was definitely a time people were not excited about language models or like
hard to remember now. It feels decades ago.
I mean, it always seemed like the best problem on earth to me, but that's
yeah. It was kind of like the deep learning people at the time maybe thought machine translation was still a bit cooler, or computer vision.
Yeah, vision was exciting for a while.
Yeah.
Why was everyone into vision?
I don't know. I guess like the ImageNet thing.
Yeah, or there's like a picture of a cat or something like that.
Oh, that was that good one. Yeah, the cat.
Yeah.
Did you work on the cat thing?
No, never actually did much in vision.
And then
run M&S.
And now you've come full circle on these Gemini 2.0 models. I see all these demos that are like vision based, and you're kind of doing cooler things in vision now. Than certainly identifying cats.
I mean, it felt like, I think even almost every early LLM person, world model is on their mind, really. Like, yeah. I actually don't feel like the early LLM researchers were even really from a language-oriented background. They weren't really like linguists. It was more, I don't even feel like understanding language was really part of the motivation for that early group. It was like train unsupervised learning at scale, do language first because it's the most like knowledge compressed, but then gobble everything up into like a big generative model and like understand everything. And it's very, very cool to see that just like continually proving out. Yesterday, we just like launched native image generation. It's amazing. I think a lot of image generation right now is just like focused purely on getting like absolutely maximally aesthetic images, but also having native image generation allows you to like really do a lot more with images, understanding, editing. You can have like interleave sequence of images and text. And yeah, once again, it's just train a generative model on lots of data to arrive at that.
I mean, you guys are obviously both big believers in like these models becoming more and more general purpose. I guess a question some folks are asking is like, you think about domains. You talked about healthcare earlier, Noam. Like, what, the model that ultimately is going to be like our AI doctor, like, is that just is that just a continuation of what we're doing in some giant model? Is there like a healthcare specific version of the model that ends up being released that is like, only has some set of data, inputted into it, or they're just a bunch of guardrails? Or like, paint that picture for me of what you ultimately think like our, AI doctor or AI, biology researcher.
Yeah, I don't really think you would need very, specific, task-specific models for something that high value, because, you probably pay like $1 a token for talking to your doctor. So it's like the LLM is like way cheaper at this point than
so in your mind, the only reason for task-specific models is price. And so if there's things that you wouldn't pay $1 a token,
yeah, like you need
targeted.
Yeah, something to analyze, vast quantities of data for marginal value, then maybe you want something cheap and task specific.
There's always this notion of like there'll be tons of like negative transfer out there, so like compartment things. I don't really feel like that has ended up being the case. If it could be measured, then that's a good reason to compartmentals. If like models, if there's no negative transfer, there's positive transfer, then just have one big model. That's like, I think, my personal philosophy. This is not like a thing which people have like uniform agreement over, though. It's like a continuous active area of research. Like, how much do you want to like specialize and spin off these expert models? But yeah, from the way I see it, it's just very simple. If there's positive transfer, put it in the same model, as long as it doesn't then become too expensive to serve.
Obviously you guys have been at the cutting edge for a while. What's one thing you've like changed your mind on in the past year?
I feel like timelines have shifted forward, and I don't mean that like in a vague sense. Like, I think the rate of progress is much faster right now. I felt like a year ago, there's obviously the field is advancing, but whenever you have a new paradigm shift, it creates this sudden acceleration. And also, actually, no, this is a pretty good one. One thing I've changed my mind on, like my mental model of like the propagation of information and how people like adopt a scientific advance has completely changed. So when the transformer came out, I think, so I was over in London at DeepMind. People thought it was a cool paper, were a bit suspicious. I eventually implemented it in our like code base over the like holiday break, actually. But it was like 3 months after the paper had come out. I eventually implemented it and tried it for like language modeling, but it was like not really getting picked up. I eventually then collaborated with someone that wanted to use it for reinforcement learning. But I'm going to say really it was like from paper coming out, maybe it was like 6 to 9 months before it was like you saw just transformers dotted around all areas of DeepMind. And that's within, like we're all within Alphabet, and it's like much easier to propagate information. I would say the speed at which the field has like picked up this test time compute paradigm, you have like many labs have already trained and released models that are like looking very good exploring the space. That was like very surprising to me. The fact that these things can like, if you make an announcement, say, and like this is important, the fact, and it's just like a blog post or something, and then you'll have people that are able to like make breakthroughs in that space and release models in order of months. That is like, that was a wake-up call for me. There's a lot more compute and a lot more smart people working in AI. I often think of things in a bit of a rose-tinted glasses way and think about like 2016 or something. And I think, well, we were very smart then, we were very creative. People are very, very smart and creative now, and they have way more compute, and there's way more of them. And so if anything is going to like be very impactful, and then it can just like spread, and like this idea can like spread all across the world, and people act on it, which is kind of crazy.
Yeah, it is kind of crazy, and just the amount of compute out there that now, whatever, a kid in the garage has more compute than was necessary to invent the transformer. So like, I mean, people always worry about just how much compute do they have, but it is definitely possible to make breakthroughs, with way less compute than you would imagine.
Yeah. Noam, anything you've changed your mind on in the past year?
I mean, I've been continuously impressed with the success of RL. It's I'd never really worked with it much before. It's like, oh, that's actually pretty good.
Well, I mean, you kind of alluded to this, Jack. Like, obviously, I think in the in the reaction to DeepSeek and all these kind of models that kind of fast followed in the test time compute space, going forward, like, do you expect the open source models to be able to keep up as with each subsequent generation of these models? It obviously seemed to happen faster than a lot of people would have expected.
Yeah, that's actually something I'm changing in my mind on. I do feel like the open source, like the ability for open source models to stay very close and competitive with the frontier is persisting. I actually thought we were getting maybe a false sense of assurance that it's happening because maybe it felt like it was converging, but then these things can pull away again. But actually, that seems to have been very impressive. I'm really, really impressed at the performance of Gemma 3 that just got released yesterday. It's amazing. It's completely incredible. The team did a really good job. And other open source models, the DeepSeek V3 was a very good model when they released it. So it seems like people are very passionate in the open source space, and they're very creative and smart, and they have compute. So I don't really see why they wouldn't be able to continually innovate. Yeah, what do you think now?
Yeah, I mean, it seems like the time gap between closed source and open source has been shrinking. I think that the technology will continue to accelerate. So, I mean, it could be that the quality gap will be large and the time gap will be very small. We'll have to see how it plays out. It's super exciting to see to see all of these companies getting great results.
Switching to some of the kind of broader implications on all the AI progress we've been talking about for society, I'm curious. Obviously, it seems like both of you in the last year have you've been impressed with the power of RL. You've been surprised by the kind of pace at which we've scaled a lot of this test time compute. Have you changed anything in your own lives, based on kind of this, probably more clarity or belief that a lot of this AI driven feature is coming? You both have kids. I know anything that you've adapted. It sounds like, Noam, I know you don't clean your garage, but I guess that was prior to this year as well.
I didn't actually do that very much either.
It does make for a good podcast. You thought about not cleaning it.
Yeah. I don't worry too much about global warming. It's we'll have AI to take care of the carbon stuff soon enough anyway.
Yeah, but I guess anything that you've thought about differently in your own lives, or in how you think about the life your kids will have.
AI in education is I don't think people are really talking about it enough yet. My son, under supervision, but he likes to talk to Gemini. It's actually insane, how powerful it is, especially if he can, he goes out to the garden, he takes pictures of plants, takes pictures of lizards, and he now has this very accurate personalized encyclopedia which can give him information. And do they adapt to that? I wasn't sure how that would work. They do. My 4-year-old son walks around talking very detailed about the plants. He'll use the Latin name. They absorb so much stuff. They're a sponge. I feel like I'm seeing kind of a type of education that I don't really think has ever existed for humanity happening. AI and education is going to be incredible. He went to school and he was like, oh yeah, I caught a lizard to his teacher, and his teacher's like, oh, that's cool. And it's oh, that looks like a big lizard. He's like, no, it's not a big lizard. It's a Western fence lizard. He's very particular about his varieties of lizards. And he's like, and I also saw a blue-tailed skink. She's like, what's that? He's like, it's an amphibious lizard that, So he starts kind of reeling these things out. And, that's just it's just obvious but when you see it. But children are very curious. They're sponges for information. And if you can combine that productively with AI, I think that's going to be really incredible. I do feel like the next generation will just seem like smarter people. That's what I'm feeling hopeful about.
Know anything you've changed?
Yeah, it is extremely hard to predict what the future will be like. We will, we'll all do our best to make sure it's that AI will be safe and beneficial. But it does it does make you think that, hey, what I do now really matters. Okay, we don't know if human labor will be materially necessary in the future, but that just means it makes more difference if you want to do something that matters materially. Go do it now, and then other than that, just try to be a good person. Whatever you find spiritually meaningful, go do it, because that's the purpose of humanity in the future. May not be about providing for physical needs. So we've got to figure out where we find meaning in the future. But we'll have plenty of time for
well, especially if your mom's already having the deep philosophical conversations with the models. Maybe we'll be able to reason our way to that. But I am struck. I mean, I feel like some other people have come on this podcast. Bob McGrew, Chief Research Officer of OpenAI, was like, look, the humanity is always going to have a role in asking the questions. The models will go off and do things. But I think to our conversation earlier, it's I think the big question is, will people always be the best people to ask questions, or will the models actually ask better questions over time? And obviously has a ton of implications. I feel like every generation thinks they're living through the most important moment in history, but it does. I guess you're biased when you're going through it, but it does feel like we are certainly in that.
Yeah, and I think sometimes like a technological advancement kind of scares people, and people have right to feel trepidation at this stage as well. But there is like, this isn't such a good example, but like even like the introduction of the television. People are like, oh, is this going to make us all just like lose our attention span? Are we going to like completely lose the will to like go out and walk outside and like have friends and things? That was like a thing people freaked out about. I think obviously now we know that was like unnecessary. It was a small piece of technology that was entertaining, maybe even has provided like a net positive to society. I think it like kind of went okay. Right now it's like there's like it's like that, but kind of on steroids. There's like very strong signs of how this helps us. There's like very good reason to be concerned about how this could not help us. So it's kind of like you have like very demonstrable reasons that have already proven out of how it's helping us. You have very like concrete arguments for how this could not go well. And I think that makes it a very interesting time too.
In some ways, we have less kind of meaning than in the past, in the sense that, like, in the distant past, everyone was like at the brink of starvation, and you're like, okay, I have meaning in my work because I have to go work hard today and get some money so my family doesn't starve tomorrow. And like today, we're living in America. Nobody's family is starving tomorrow if you don't work hard. So that okay, that's less meaning than we used to have, and we've found other sources of meaning. Future, more of that in the future as hopefully AI improves our physical situation.
How worried are you both about AGI risks?
I would say moderately. Yeah. It is hard. It's often difficult to find examples of creating something which becomes far more intelligent than its creator, but then like still it like acts in predictable and useful ways for its creator. And I think that like class of argument is concerning. There's also just like more practical like kind of AI and society implications that we've kind of touched upon, but like making sure that AI is like constructive to the economy and and people can offload their lifestyle, and we don't have like sharp changes in like the employment landscape and things. That's super important. Both of those are often on my minds. Then there's just very pragmatic things when we're always putting more capable models out. We're very excited as technologists to develop and ship things, but we also, I think we have a pretty good balance of then internally having another group that's going to be thinking about this much more holistically, and like how can we make this launch safe? What are some unintended consequences? Which I think has been pretty good and is like super important. So I'm glad that happens.
Yeah, I mean, I agree. We need to. Yeah, I'm not afraid, but we definitely need to be working on all the safety aspects of all of that. And there are examples of we create something that becomes smarter and more powerful, in that we have kids and they're coming and they're smarter than us, and
they're already detailed encyclopedias of amphibians.
But then they become teenagers. And then you solve the alignment problem after.
But so, I mean, hopefully, if we respect our parents and treat them well, the AI will learn that from us. Yeah.
Just have to have a lot of tokens on the internet of people being really respectful toward their parents.
Exactly. Yeah.
We have to stop pushing the robots over.
Respect for creators.
Yeah, exactly. That feels dangerous. One thing I did want to ask you about, Noam, is obviously, in your previous in-between Google stints, you'd spent a lot of time kind of building out character, and you thought a lot about kind of that product space of what, AI companions and the ability for folks to chat with all sorts of different kinds of people. What do you feel about where that space is today? What kind of problems do you feel like we still need to solve there?
Yeah, I mean, it's interesting because the reason main reason I left Google to start Character was I thought that the biggest thing that the LLM industry could use was an application where like anybody can go and interact with LLMs and use them and discover use cases that were good for them. And because this was before before ChatGPT launched,
Right.
before Gemini launched. I mean, mission accomplished. Everyone's out there talking to LLMs now, which is kind of different from how things are now. I guess the other thing was, going into Character, we were not really focused on, hey, this is going to be an entertainment product or something else. We kind of just went in with an open mind, and we're like, okay, we're going to just put this out there in a general way. We're going to help people conceptualize this as, okay, this thing can, take on different personas, meaning it's a very, very general technology. See what you can make it do. And definitely we found a lot of people are using it for entertainment. I think partially because like at that point in the technology, like, okay, like nobody's figured out how to make this thing not hallucinate. So people are going to use it for, for applications where hallucination is actually a feature.
Right.
Such as entertainment. And, that's, I think that's worked pretty well. I know a lot of people like using Character. What were you asking?
I guess, what do you think the future of that? Obviously, there's this early behavior. A lot of people interacting.
Yeah. What is the future?
What does it look like 5-10 years from now?
That's a good question. I do not know. I mean, I do think, people are going to, I think people will always want relationships with humans because it's spiritually more meaningful. But I think people will, like having AIs that are kind of more in human form for things they want. I mean, like imagine, you just get elected president and you get your piece in the cabinet to advise you wherever you go. I mean, that
have a whole AI cabinet.
Cool. Yeah, you get your own personal AI cabinet. You get your whole
a good AI summarization of all the secrets that you need to know.
Yeah, or maybe you're you're CEO of your own AI company, so you get a lot more productivity. I guess that's maybe in a lot of those cases it's less about the personality and more about the productivity. But I think to the degree that people like interacting with something that feels human, probably we'll see a lot of kind of AI that feels more human in various ways.
And you think progress in that space is just about the models getting better, or is there a whole other set of just human-computer interaction, product questions that need to be solved?
It's a good question. I mean, I think the models getting better is pretty big, but then part of it is for whoever is running the application to decide, okay, what are we going to what are we going to let people do? I think users are probably will be pretty good at specifying, okay, what do I want for an interface, and it'll be mostly about do we want to let them specify that?
Totally. Well, look, both of you, fascinating conversation. We always like to end with just a quick fire to get your take on some overly broad questions that we cram into the end.
Sounds good.
Okay.
So maybe to start, what do you feel like's overhyped in the AI world today, and what's underhyped?
I personally feel like the Arc AGI eval is overhyped.
Well, that's very spicy.
Yeah, I think actually maybe the progress has been quite slow because a lot of researchers just don't feel particularly inspired to do kind of these very specific types of puzzles. We did a lot of that in 2015, 2016. And then we kind of felt you can if you know the puzzle domain, you spend a lot of time like fixing all the like actual bottlenecks, like maybe acting on these large grids is like a little bit finicky and stuff, and then you make a lot of progress, but then you don't necessarily continue on like building something that's really AGI and useful. So I feel like I personally had a transition from like all these like synthetic tasks like to then going to just model natural language, and I felt like that was a dragging in that direction was like a much more AGI thing in the long run.
Anything else that comes to mind for you, Nova? Overhyped or underhyped?
I don't know. I think AGI is underhyped. AGI LLMs are just still massively underhyped. I think people are, I don't know. People are still like thinking about it like it's only like that it's going to be about some silly $1 trillion product.
Yeah, I heard you say in another pod that a trillion wasn't cool anymore. Yeah. Quadrillion was. So, yeah, exactly. You got to put the Dr. Evil up. Obviously, it would be a gross misallocation of societal resources to take you away from building models to like build applications. But I am curious, like if we were to say today, go build an application, like what do you think are the most interesting? You've talked about education before, but any other areas that come to mind that you think would be fun to go build apps on top of these models?
Well, I do think I think it's actually very cool how many like apps that have been trying to like break into this agentic space, and people then like expose it and say, oh, this is just a wrapper around a known model. But like there seems to be a lot of value in like actually having the right like app experience if you want to actually have a model do something useful for you, like act and do something useful for you. So I feel like okay, and in the agentic space, I think code is very crowded now. But I do think there's a lot of other things that I would find it useful for a model to automate for me that goes beyond maybe like a chat experience, but it's actually going to be going out and doing useful things.
Yeah, I mean, I'd say code is underhyped. I think it's huge. I think it's huge because for one, humans aren't even that good at it. Things like code and math are not super designed for that. And then it's one of these things that will help self-accelerate. If build an automated software engineer, researcher, and then it'll build the next better AI. So the combination of of engineering and agentic, something that can control surfaces broad enough to do the job of an engineer. I think if I were to focus on applications, that is what I would be focused on.
How different will the infrastructure needs look for test time compute models, versus these massive pre-training?
You mean like in terms of like hardware?
Yeah, in terms of the hardware requirements, distributed data centers, all that.
Yeah. I mean, it's a pretty rosy story, I would say, right? So if it turns out that building AGI becomes like mostly an inference problem that can be much more distributed than maybe like synchronous large batch training that happens in pre-training, I think that means that we can be much more flexible with our compute. But yeah, it's going to mean we maybe don't mind the model training across data centers as much. Maybe it can be spreading out actors that are going to go off and get experience and things and send that experience back from like many different data centers. They don't all need to be like have very strong, fast interconnects. So that is also going to drive price down as well, because then we might start to like really optimize towards such a setup, which is intrinsically cheaper. The cool thing is at Google, we kind of have like this co-design link with the TPU team. Yeah. So we're always like feeding them like the profile of like how we're spending our compute, which allows them to tweak the chip design and the data center design, within a couple of years time frame, which I think is really, really like kind of motivating.
The fact that you can be distributed, as Jack said, gets better. I mean, the thing that gets worse about inference than training is that you lose a lot of the parallelism in the transformer. That just naively using transformer, you end up you end up memory bound, like looking at your attention keys and values, for every token that you're generating. So. So there's like a lot of great work to do in both attacking this from a model architecture perspective and from a hardware perspective, frankly. So, to get ourselves closer to the point where we're taking like the massive computational power of the chips we have and making ourselves able to like fully apply that to inference.
I want to leave the last word to you. Where can they go learn more about you and what you guys are doing?
Yeah, well, we have a new and updated Flash model that applies thinking that's considerably stronger than the last model we released in January. It's out on the Gemini app. I would definitely encourage people to try that out and give us feedback. We have been incorporating developer feedback, user feedback into each model series. So I think that's a good, that would be one thing I would encourage people to do.
What Jack said.
Yeah. Well, thank you both so much. Seriously, it's such a pleasure to be able to do on all this with you.
Real
Thanks.
pleasure.
Yeah.
Thanks.
Hey guys, this is Jacob. Just one more thing before you take off. If you enjoyed that conversation, please consider leaving a 5-star rating on the show. Doing so helps the podcast reach more listeners and helps us bring on the best guests. This has been an episode of Unsupervised Learning, an AI podcast by Redpoint Ventures, where we probe the sharpest minds in AI about what's real today, what's going to be real in the future, and what it means for businesses in the world. With the fast-moving pace of AI, we aim to help you deconstruct and understand the most important breakthroughs and see a clearer picture of reality. Thank you for listening, and see you next episode.